We're going to start by looking at 13.5 and how to graph some of the other functions. So, for example, we want to talk about how do I graph y equals the tangent of x? Well, the thing about tangent of x, and the same thing is going to be true of cotangent and cosecant and secant, is we introduce something into our graphs that cosine and sine did not have, and that is what happens at for example, tangent of pi over 2. If you remember, tangent of pi over 2 is undefined. And as it gets closer and closer to pi over 2, you get closer and closer to the denominator being 0. Because remember, it's when you're looking at the unit circle, tangent is y over x. Another way we can think about it as sine over x, sine x over cosine of x. And this is how we're going to approach this, is we're going to think about it in terms of sine and cosine, because I think it's a way of helping us to understand what's happening. So let's do graph sine and cosine really quick with an x square of pi over 2 like we would like to do, and then a y square of, let's say, at 1/2, just to make so we can see it a little bit better. Okay, and so if we graph those, remember the sine curve is going to just look like this, where the amplitude is 1. I did a y square of 1/2, which is why it looks like 2 on here. And so this is what our sine curve looks like. And then our cosine starts up here instead, and so we'll do it in red. And so it looks like this. Very, very similar, but just shifted over, and it turns out it shifted over pi over 2. And so that is our cosine graph. So when we're talking about tangent, let's start thinking about it at different points. And so there's some significant points that I want to show you. The most significant points are at the vertical lines here, which are the 0, pi over 2, pi, 3 pi over 2, 2 pi, and so on and so forth. So when, since it's sine over cosine, when sine, so at the 0 and pi and 2 pi, negative pi, negative 2 pi, all of those, sine is 0. And so at all of those points, the tangent is 0. So the thing to remember is y equals tangent of x is equal to 0 at 0, pi, 2 pi, negative 2 pi. And that's because that's when sine is 0. And then at pi over 2, the cosine is 0, right? That's what that value is. And so we have cosine 0, and it's at all the the pi over 2, 3 pi over 2. And so when cosine is 0, your denominator is 0, and so it's undefined at that point. And so y equals tangent of x is undefined at pi over 2, 3 pi over 2, and so forth. And then the other one I want you to notice is there are these points in here where the sine and the cosine run into each other. All of those points happen at the pi over 4s. They're halfway in between. And at that point, the tangent is 1 or negative 1, depending on if you've got positive or negative values involved in what you're doing. And so we have to kind of think through when's it going to be positive 1 and when is it going to be negative 1. So let's graph y equals tangent of x. Well, the things that we just discussed, so with y equals tangent of x, we know that it's 0 at these points. And so we'll do our scale the same as we did over there. So for the tangent graph, at 0, pi, 2 pi, negative pi, negative 2 pi, we know that our tangent graph goes through those points. We know at the pi over 2, 3 pi over 2, etc., it's going to be undefined. And so what happens whenever you have undefined in a graph, that is an asymptote. So what we're going to do is at each of those, right in between where it is 0, we're going to have asymptotes. And so this graph is actually made up of a bunch of asymptotes. And then we know at the pi over 4s, it's 1 and -1. We know that tangent is positive in the first and the third quadrant. So it's going to be 1 here, here, here. Actually, it should be 1, not sorry. Yeah. So it's going to be 1 right there, 1 right here, right here. And then -1 in the second and fourth quadrants, right, which would happen so negative pi over 4 is in the fourth quadrant, that's why it's negative. Pi over 4 is in the first quadrant, that's why it's positive. And then what happens is, the last insight to get on this graph is, as we approach pi over 2, so as we approach pi over 2 right here, as the y value, as the sine value gets closer and closer to 1, the cosine value gets closer and closer to 0, and so the denominator gets arbitrarily small, which the numerator is just going to get bigger and bigger and bigger, and so the overall function is going to get bigger and bigger and bigger. So what ends up happening on the tangent graph is it looks like this. It essentially goes all the way right by those asymptotes we described. It goes all the way to the negative to the positive values. And so that is what y equals tangent of x looks like. Some things to notice: you're not going to have a min or a max because it goes off to infinity in both the minimum and maximum direction over and over again. And you're not going to have an amplitude. You are going to have a period. Remember, period is how often it repeats. And it repeats from 0 to pi. And so the difference between tangent and cosine and sine, instead of having a period of 2 pi, it has a period of pi. So if you have one of these, where something like y equals tangent of 2x, well, it's going to be done the same way, where you're going to have your period is just going to be, instead of 2 pi over b, it's going to be pi over b, where b is whatever is in front of the x-coordinate here. And so your period for y equals tangent of 2x is just pi over 2. And so it just cuts everything in half this direction. And so you just do your x scale would be pi over 4 instead of pi over 2. And then your graph would look exactly like that one. And so that gives you at least a start on tangent. If you look at cotangent, all the logic of cotangent is going to be the same, except for this time it's cosine of x over sine of x. And so now our asymptotes happen when the sine of x is equal to 0. Remember, sine is equal to 0 at 0, pi, 2 pi, and so on and so forth. So the cotangent graph looks exactly like the sine graph, except our asymptotes happen at pi and negative pi and negative 2 pi and whatnot. But other than that, it looks exactly the same, right? You're going to have your 0 points in between. You're going to have your 1 points in between those for all the same reasons we just discussed. And so when you're graphing these, and so it turns out to look like this. And so it looked exactly like the tangent graph, just shifted over pi over 2. So again, it's very similar, but it's just shifted over pi over 2.